Hey, Honors Chemistry, it's Wednesday, the 13th of May, and we're getting pretty close to the end of the tunnel. Turn to page 599. This is, I think, my fourth day on chapter 19, section 1, page 599. This will finish up section 1, and hopefully I'll go into section 2. You got to see section 2. Okay, did I say 599? Go back to 597. You're going to see the oxidation of copper when you drop a penny into some nitric acid. And so what do you have here? Well, you have copper dropped into nitric acid. That's nitrate, 1 hydrogen. And you're going to get copper nitrate, copper 2 nitrate. Oh, there's 2 of them. And you're going to get some nitrogen dioxide. And you're going to get some water. Now, when you go ahead and balance that thing, you're going to get 1, 4, 1, 2, 2. All right. I'm going to make a point to you here. Is this oxidation reduction? Let's find out. Copper is 0, oxidation state. Hydrogen is +1. Nitrogen, well, let's see. This is -2. There's 3 of them, so that's -6. -6 + 1 is -5, so this has to be +5 for nitrogen. Okay, then you got copper over here. Let's see, oxygen's -2. Copper, it's copper Roman numeral 2 nitrate, so it's +2. Now there are 2 times 3, which is 6, times -2, so that's -12. And you got +2, so that's -10. And -10, you got 2 nitrogens at +5 apiece. Okay, then over here we got -2 for the oxygen, so that's -4. And therefore the nitrogen must be +4. And this oxygen is -2. This is +1. And so -2, +2, they balance each other out. So what do I see here? I see some oxidation in nitrogen. No, reduction. I see oxidation with copper. Copper goes from 0 to +2. And I see some reduction in nitrogen. No, not right there. That's +5, that's +5. We're going to go on over to here. Boom. And that would be reduction. So when we talk about this, go over to page 599 to the last 3 lines. 599, last 3 lines in the reading. It says there, nitrogen is reduced in this reaction. Well, yeah, it was reduced because it went from +5 to +4. Usually we refer to the oxidation or reduction of the entire molecule or the entire ion. Instead of saying that the nitrogen atom is reduced, we say that the nitrate ion, where's the nitrate ion? Right there. We say the nitrate ion is reduced into nitrogen dioxide. Because it goes from +5, +4 for the nitrogen atom, we say that this whole unit, nitrate, is reduced to nitrogen dioxide. And of course, we say that copper is oxidized. All right. Just thought I'd like to get the terminology into your little old brain there for when you go to college. Here's another thing for when you're going to college. Look at 599, number 5. Let's start with a reaction. The reaction is going to be Let's see, number 5, use the following equations for the redox between aluminum 3 plus and sodium. What does that aluminum 3 plus mean? It means that they're omitting the anion. The anion would be the negative ion. What could you hook up to aluminum when it's a positive 3 ion? Could you hook up a chloride ion? Could you hook up a sulfide ion? Oh, AlCl3. You could go sulfide. So that would be +3 -2. Okay, you could call it oxide. And so again, that's +3 -2. So what they're saying is some compound consisting of aluminum ions. Any of these would work. If you put it up against sodium, you're going to get a single replacement of the sodium with the aluminum. And so what they want to do is, let's just pick one. Let's go chloride. Let's say sodium and aluminum chloride. Is going to form sodium chloride. And aluminum is going to go dance by itself. Is that redox? Sure it is. Because the aluminum goes from 0, elemental state, to +1. And so that's oxidation. And the aluminum goes from +3 down to 0. And the chlorine is -1, and the chlorine is -1. It does not change oxidation state. It is a spectator ion. It just comes along for the ride. So let's take a look at number 5, the redox reaction. Not the oxidation half reaction, not the reduction half reaction, but the redox reaction. They say the redox reaction is this. 3 Na. By the way, we need to balance this thing out. 1 Na, 1 Na. 1 aluminum, 1 aluminum. 3 chlorines, 1 chlorine. Good. Fix the NAs. Okay. Looks like you got it right now. And so they say the redox reaction on number 5 is 3 Na plus Al 3 plus. So aluminum plus the aluminum, sodium plus the aluminum ion becomes 3 sodium ions and aluminum, elemental aluminum. So what's missing from the redox? This is a balanced redox reaction. How is it balanced? It's balanced by atoms, 3 sodiums, 1 aluminum, 1 aluminum. So they say that's balanced by mass, and it's balanced by charge. Over here, we have a charge of 3 plus. Over there, we have 3 times a +1, which is 3 plus. So it's +3 on this side of the equation and +3 on that side. Of course, this is 0 and that's 0. You got it? Okay. And so it's balanced for mass and it's balanced for charge. And so it's a balanced redox reaction. Up here, this is called a balanced chemical reaction. And that includes the spectator ions. This does not include the spectator ions. And this is the way it's going to be listed all the time in college. When you read your textbook, you're going to say, whoa, there's stuff missing in this reaction here. Well, that's because they just took the spectator ions out of the picture. And how do they get to this thing? Well, here's how they get to it. I'm going to go ahead and go a different color so you can see it. I'm going to go red. They do the oxidation half reaction. And they say that 3 sodium ions or 3 sodium atoms are becoming 3 sodium ions. Okay? And then the reduction, they're saying that an aluminum ion at 3 plus is becoming elemental aluminum. And then they go back and they say, over here we have positive 3. And over here we have 0. So you add electrons to the more positive side. So you're going to add 3 electrons. Now it's not only balanced by atoms or mass, 3 atoms of sodium, 3 atoms of sodium, but it's also balanced by charge, because the charge over here is 0 and the charge over there is 0. Because 3 positives plus 3 negatives is 0. And guess what? I bet there's going to be plus 3 electrons over here. Which is the more got 1 aluminum, so that's good by mass. And we got positive 3 over here, we got 0 over there, so we got to have 3 electrons. And that is how they get to the black ionic redox. Because what happens? And this 3Na, 3Na, aluminum, aluminum ion, 3Na ion, 3Na ion, aluminum, aluminum. Pretty easy, huh? That's it for section 1. We're going to do section 2 tomorrow. And then tomorrow, I just want to tell you, I'm probably going to have you upload your homework, because tomorrow I don't have any ABCD type questions, because it's just going to be a long redox reaction solution. And if you want to get started, read page 601. Read page 601 to 605. 601 to 605. In fact, that's going to be my homework for tonight. Look through 601 to 605. That's question number 1 in your homework for tonight. Did you read that? I'm not asking you to know how to do it, just did you read it? 601 to 605. And then the second question on your homework for tonight is on page 600. And what is the solution? What's the menu to get the skunk spray out of your dog? All right, so that's in that piece on page 600. So I have 2 questions. That's it for tonight. See ya.